Well, no sooner did I start messing with this last night and the battery on the camera died. So I quit last night, charged the battery overnight, and now we're ready to go. And hopefully today we're actually going to get this motor running, this lathe, so we can at least watch the spindles work and the compound drive work in real time. Anyways, it's actually Thursday, February 13th, and the only reason I'm home today is because the kids had no school because we had a major snowstorm. Well, we had 8 to 12 inches of snow. So, got a little time to kill. I've done my snow blowing deeds for the day. I'm not going to go back out tonight. And figured I'd relax a little bit. Got my herbal tea. Changed into dry clothes. We're ready to go. So, what I did was I loosened up these mounts right here because I had determined that the new belt I got is going to be too short for where this was positioned. So if you look at the way this works, if you loosen up these arms right here, I can now tilt this up like that. I can definitely get the length that I need. But then I've got a problem where this is going to be offset, and I'll show that in a minute. Right now what I'm going to do is I'm just going to permanently, hold on a second, I can get in. Well, the boss man got out of work early today. They released her out of work at 2 o'clock because of the bad weather, so had to attend to that. She had a question for me. All right, where was I? Oh yeah, so I'm going to mount this thing on here semi-permanently. Going to use the hardware that I had on that was used to hold this motor onto the Binks paint sprayer. Might as well. Now, those of you more astute observers may have noticed an Allen wrench sticking up out of this pulley, and you may have thought, "Oh, wonder what he's doing there. Hope he doesn't start this motor because that'll send that flying. Stick right in you." Anyways, the reason why I have this on here is because I already broke this loose because I've got a problem here where, because of the way these slotted holes work on this mount, the holes aren't slotted just in one direction or the other. They're actually kind of slotted with a dog-leg shape to them. And what that allows you to do is that allows you to have a lot more leeway when it comes to mounting different motors on here. I'm assuming that they planned it that way in case you needed to change the motor out. So the problem I'm having right now is I've got this thing mounted on here, and what's happening is this pulley is actually change the angle here so you can see what I'm... Okay, so I've got the motor fairly straight as far as the mounting goes, and what we've got going is if we run a straight edge here, you can actually, I don't know if it's really coming out on the video, but this pulley is out too far this way. In other words, right now it's kind of aiming more for about here. So what I want to do is I want to see whether or not I can remove this pulley and flip it around, because right now the end of the motor shaft is flush with the end of the pulley here, so there's a very strong possibility I could just pop this pulley and reverse it, and that will have the sheave of the pulley actually about this position, which looks like it might be a good fix. So as luck would have it, the set screw broke loose pretty easily, nice and loose, wasn't seized. But that pulley has been on there a long time, so we're going to need a puller. Now, depending on how stuck something is and other different parameters, that's what I base my choice of puller on. And this particular puller I'm using here, this is a style of puller that can be set up as either a 3-jaw or a 2-jaw puller. 2-jaw pullers are a little easier to manage, so I always like to try the 2-jaw first, and if I can get away with it, I'll just pull it with a 2-jaw, and then if it's really stuck and stubborn, I'll go with a 3. Set up a light behind me, improve the lighting on this situation here, so I'll work from this side. Yeah, piece of cake. So that, you know, that's the kind of situation where a 2-jaw is perfect. I'm not putting enough force on the sheave to bend the pulley, and it's coming off nicely, like nothing. Piece of cake. So let's see. And this is not a key, doesn't have a Woodruff key. It's just got a flat spot on the pulley. And you know what? You can actually, if we can get a shot of this. You can actually see right on the end of the shaft here. Not sure if this is focusing or not, but you can actually see the ghost of another indentation on the flat spot here. Here's one and here's the other. So that tells me this is not the first time that somebody has switched this pulley around, reversed this pulley on this shaft for whatever application. Alright, I just took a quick minute there to clean that pulley because it was pretty dirty. And now I'm just going to give it a love tap. See where I wanted to get it aligned perfect so that when I tighten my Allen screw, it's coming down perpendicular to that flat surface, and it's a little off. I think I really should have just cleaned the shaft. Clean that bore out, clean the shaft up a little bit, make my life a little easier. Because if I look down in there under the light, I can see some rustification in there. You know, there are lots of little tricks for cleaning out a bore like this. If I've got a small enough brass brush for my Dremel tool, I'd love to put it in there and zip that around. You know, when it's a little larger and my one that's smaller is all chewed up in places. I just take a strip of sandpaper, wrap it around a drill bit that's kind of in the ballpark of the area, the size that I'm dealing with here. And if you wrap it tight enough, you do a better job than I just did. And you can usually slip it right in there. Try that again. Come on. If I put that down. There we go. Now we're cooking. Now we're cooking with more gas. And there's the other side. Almost dropped it. Oh yeah, sweet. Alright. Now as for cleaning this, cleaning the motor shaft. Ah, well, that's just a matter of using the motor. Some kind of trick. You have some kind of trick up your sleeve? Oh. This was a perfectly round shaft. The piece of cake with the flat there, it kind of bounces the paper off, but that's still, oh, that's beautiful. Check that out. It's beautiful. Look at that. There's actually some, a little bit of rub marks right there from something. I'm not going to worry about that. Oh, look at that. See, you should have done that in the first place. Look at that. It slips right on. I can rotate it a little bit if I have to get it set up just right. And I'm putting it on backwards because the whole purpose of this was to flip this around. Hello. Guess I should check the alignment before I tighten that in case I want to tweak it a little bit. Get this light out of the way. Oh, I gotta loosen these bolts of these things swim. I don't even have the tension on this. Way too short. What's going on here? Why isn't this moving? I can see the slot's getting a lot more room there, but for some reason it won't go past that point. Can't figure out what's holding that. Alright. Take the screws completely out. Drop these right off. Oh yeah, see that's that side. Okay. We'll figure out what that is in a minute. Right now I just want to see if this is going to work. Alright, so tension on. Oh, I see what the problem is. What I've got is I've got underneath here, I've got a, oh that one loose, still loose. I've got a big nut that's actually so large it's interfering with the movement of this bracket on this side. So quick adjustment will fix that. Okay, I've gone and made my little fix there to get that nut out of the way. So what I've done now is I've got this on the almost full lock position. Just a little bit further it needs to go, and I'm putting just a little bit of tension on here, and I'm going to tighten this down, and then hopefully that'll end up corresponding to the perfect amount of tension on the motor. By the way, my alignment here is almost dead on, so I can tighten that set screw with a chance. What I started to say was the idea being that hopefully this will correspond to the optimal tension on the belt, the main drive belt, when I pull this all the way down to the full position. Alright, so it's there. That's what I'm thinking anyways. So now, let's see, probably should give it one spin just to make sure that yeah. I can tell you, just by me rotating this with my hand, I have serious doubts about this motor, this split phase motor, having enough starting torque to start this lathe. I'm thinking what's going to end up happening is you get the mass of you get the mass of this chuck in the spindle, and on top of that you've got all the losses involved with all of these pulleys and everything. So I just think it's not going to work. I hope I'm wrong. But I'm not. Cripes. That's really hard to turn. That poor motor. Starting to, that was just getting ready to give up the ghost. That was a death growl if I ever heard one. If I relieve the tension on this, it would help. It's way too little, honestly. I just tried, just curious, tried it there. Not quite the full amount of tension on it. There was excessive motor tension I had on there. It's about as much as I want to run it until I get those automatic oilers and the bearing caps filled with oil. Still hadn't gotten my oil can with the little, syringe nozzle on it there, but I was able to fill these bearing cups. I didn't video it, but basically what I did was I took this spout off of this 90 weight gear oil thing and I used it as a tiny funnel. And on the first one I overfilled it and got oil all over the place, which is just what you want to do after you spend all that time cleaning the lathe, is spill oil all over it. But I got it cleaned up pretty well, and let's face it, it's not going to be long before I get oil all over this thing if I actually use it. So, anyways, I certainly don't see any difference there in the feeling, the way that's running. I'm going to have to figure out what kind of grease should be used in this jack shaft assembly, and then also figure out exactly how you go about installing it in there. What if you're supposed to what if that's holes threaded for a Zerk fitting? Maybe you put a Zerk fitting in there, pump grease into it, and then take the Zerk fitting off, put the cap back on. That would make some sense. But at least now I know I have oil in those bearings. So the other thing that I was thinking about was, you see some little holes right here on the top of this motor bedding. That is where some machine oil should go. I've got some light machine oil upstairs in the office in my electronics toolbox. So I use that on small motors and things, so I'm thinking I might go grab that, put a little bit of oil in there. But just for giggles, let's give this a listen again. Go get that oil for the motor. What I really wish I had was, are you familiar with the 3-in-1 oil? The little can with the little precision applicator. That company actually even makes an oil specific for electric motors. I don't know if it's still on the market or not, but that's the perfect, that'd be the perfect oil for this application. I just went up and checked, and I had this oil here. This is called sintered bearing oil, and this is for capstan and head drum bearings on videotape recorders, VCRs. Anyways, back in the day when I was repairing a lot of these, we used to use this oil on the capstan bearings. But that is almost all gone. And then I also have, this is PRB is the company that put this out. This is delicate machine oil, paraffinic lube. It's interesting. And then I've got this is from GC Electronics. This is the Pocket Precision Oiler. And what's nice about this is it's almost got like a large syringe tip there, so it's really good at when you just want to put like a drop or two of oil on a shaft and let it run down into a bearing. That's what that's good for. I got quite a bit left in that, but we're going to try and preserve that. So I think I'll put in what little is left of this oil, and then I think what I'll do is I'll put some motor oil in this and get some motor oil in there. Oh, this motor probably hasn't seen oil in a long time. Oh yeah, much better. Of course, I'm being sarcastic. I hear no difference at all. But I guess now I can redo this tension that I was worried about. So again, if I put it back to the full tension, right there, it probably is putting too much force on this shaft this way, and it's not going to allow it to start. So what we're going to do is we're going to readjust this and take some of that tension off. Well, I'll tell you what, I've got quite a bit of tension taken out of this belt now, and it still doesn't want to start when it's in full tension position, which tells me that these belts are too tight for the likings of our motor over there. So we've got either one or two choices. We can either change the motor to a higher horsepower or take some of the tension out of these belts. These belts are awfully tight. And you know, I tightened them that much because they were slipping so much the other day. But well, one of the major drawbacks to having the camera set at a higher resolution is that the 4 gigabyte card that I have in there fills up quicker. So it filled up on video when I was discussing my plans at changing the tension here on the belts. So what I did was I went back here and I made adjustments here on the jack shaft, took some of the tension out of the belts here. These are actually still a little, maybe even still a little too tight. I might want to revisit that. And then I changed the tension here, and I actually got it running. And then I had to go up and take all the video clips off of the card to empty the card out. Decided to have supper while I was up there, so it's been a few hours. Just curious to see if it'll start after having sat. You can see how long it took for it to spin up. So I think maybe I'll tweak these just a little bit more. Loosen them just a little more. So let's see if that's going to be too loose or not. Well, at that tension right there, the pulley definitely feels freer. Alright, let's see how fast this comes up to speed. That's better. See that? Chuck's humming right along. That's pretty high speed right there. That actually, it's in direct drive right now. And it's on the pulley setting. That's top speed for this lathe right there. I don't have a tachometer, so I can't tell you how fast that is, but it's cooking. So now I'm going to switch this to this pulley and can keep it direct drive. So you basically get 3 speed changes here, and I'm not going to bother with the middle one. I'm going to go, well, what the heck. Alright, so now I'm on, this is 1 speed down. A little slower. And now we'll go to the lowest speed setting in direct drive, which is right here. I like also with the tension the way I have it set right now, this is much more manageable. Once I have the lathe securely bolted down to the bench, I'll be able to easily one-handedly push that back. I put too much oil in these cups because I noticed on this side over here it's actually slinging a little bit of oil out at me. Alright, so this is lowest speed in direct drive. Okay. Now I'm going to go to the next lowest speed attainable, which would be to move this back to its highest speed, but to engage the compound drive, which is a matter of rotating this. So this is highest speed in compound drive. Highest speed and compound drive. Okay. And now we're just keeping compound drive and move this over to the next pulley. Now, move it over to the last position, and this is going to be the slowest speed attainable on this lathe, given the RPM motor that I have on here. So if I wanted to get anything slower than this, you'd have to go with a slower motor. But, as I'm about to show you, I can't imagine going slower than this. It's pretty darn slow. Kind of neat.